So we're going to go ahead and move this forward. I would encourage you to get with Maria afterward if you have questions, but thank you very much, Maria, for the presentation. Let's go ahead and bring up our next presenter. We have Peter Willis, who is a chief researcher at BT. You may remember Peter from his work on PBBTE, but he is now focused on virtual network functions. Peter.
Okay, thank you. You've got a long memory if you can remember PBBTE. Okay, so some of you may remember I said something about OpenStack being NFV challenged last year. I gave it 6 particular challenges, and I'm going to update you on how that's progressing. Just trying to find how to advance the, oh, there's a clicker here. There we are. So you all know what NFV is, so I'll get rid of all those horrible boxes. Just point out that right from the beginning, we were thinking about orchestration and automatic and remote install. You notice the spinning cogs up in the right-hand corner there, top right-hand corner, and one of those cogs could be OpenStack. OpenStack, massive project, delivering tools to manage cloud infrastructure, and NFV is a bit like cloud, so really we did have to have a close look at whether we could use OpenStack for NFV. Distributed NFV, you're probably all familiar with. That's where we push the NFV functions right out to the edge of the carrier network, even to the customer premise. So when you're on the customer premise, you're potentially talking about millions of sites, at least hundreds of thousands. This is the high-level OpenStack architecture. It's made some, best described as, it's made some assumptions about that network being secure and high performance. So you could describe this as the square peg, but the round hole. And that was the issues we were trying to address. So I came up with these 6 issues. I won't read them out now. I'll go on and sort of talk about them. Not in the order that you just saw there. Challenge 2 was service chain modification problem. OpenStack's no primitives that supports that. And reprovisioning a service train from scratch just took too long. It says more than 5 minutes outage there. It can be a lot more than that in our testing. So what solutions to that? So instead of trying to reconfigure that service chain by rebuilding it, why just not statically connect all your virtual network functions into the vSwitch and then control the vSwitch with an SDN controller? And that'll work, but it's adding extra complexity to your solution. You've now introduced a whole new stack that you need to manage your distributed NFV solution, especially for virtual CP. It might be overkill. There's a new project called the OpenStack Service Chaining Framework. This has added extensions that allow you to do a port chaining method, so you can now connect these VNFs together using this port churning method. You don't have to reconfigure the VNFs. You don't have to reinstall them. So that sounds like a good solution. You don't need an SDN controller. It's all built into the OpenStack framework. So that's great. There's the IETF network service header that's used for building service chains. That feels as though it's overkill for a virtual CP solution where you're talking about a single tenant solution on a customer site. Adding a header just to go across the vSwitch within a single compute node sounds overkill, so I wouldn't do that. Scalability, obviously, this is an essential figure. How many compute nodes can a controller manage? And the answer is it's a piece of, how long is a piece of string, which obviously isn't a good answer, because I need to plan that if I'm going to build a global network using OpenStack. So there's some methods that people have been developing for scaling OpenStack. Wowie developed OpenStack cascading. They've claimed to have tested that to 1 million virtual machines and 100,000 compute nodes, and that's kind of the sort of scale I'm looking for, which sounds like worth looking at. The other approach is to put an OpenStack controller on every node, and we've seen Wind River implement this, and Charlie Ashton will be talking about that later today. That seems to be a good approach if your controller doesn't consume too much resource. So you've got to bear in mind in the virtual CP use case, actually some of the CPE are pretty small. You know, the atom-powered nodes, you don't want to consume a lot of resource just on your management plane. Then the other solutions are basically don't use OpenStack. Use something like libvirt and RESTful interfaces into libvirt. But then what you're doing is you're pushing some of the problems into the orchestration layer. Effectively, you end up recreating the wheel. You know, you're just recreating what's already been done in OpenStack. So although I've seen vendors do that, you know, the RESTful API into libvirt as a way of managing virtual CPE, you've got to think about what you're doing in the orchestration layer and what you're reinventing from scratch. Then there's startup storms or stampedes, as some people call them. So you imagine you've got this controller, potentially hundreds of thousands of nodes connected to it. If there's a network fault, a fiber breaks and it gets restored a few minutes later, then you're going to get all the compute nodes trying to connect to the controller, and that's going to knock the controller over. And you know, we see this sort of problems quite typical in networks. We've seen it in PSDN scenarios. We've seen it in BNG, BRAS scenarios. So we do know this sort of thing happens. So how do you manage that? So you could start to look at rate limiting the messages that you're sending back to the controller, and there's methods to do that. You could avoid using OpenStack altogether, so go back to the solutions in Challenge 3, where either you're using something like libvirt, or you use a controller per node, so you've only got one node per controller. That's not going to suffer from this sort of stampeding issue. And you could also look at things like putting random backup timers, so when the compute node tries to connect to the controller, if it's unsuccessful, it just waits a random amount of time and tries again a bit later. So this will allow, after a major network event, the controllers to come back in a controlled way. It will take a bit of time, but it will come back, rather than never being able to come back at all. Then there's the issue of securing OpenStack over the internet. And some people don't believe what I said here about how difficult it is to do, but you know, I did this. I put a node out on the internet and connected my controller to it. Had a firewall in the way, and I had to reconfigure that firewall to make the solution work. You could go and try it yourself, and you find out it does actually require a lot of pinholes to make it work. So how can we secure OpenStack over the internet? And we need to secure both ends, secure the compute nodes on the customer premise and secure the controller. So Liberty has introduced tokenless client certification, which goes some way to helping with security there. And the more obvious way of doing it is to build sort of a VPN over the internet using a technology like IPsec. That seems fairly obvious and straightforward, widely used technology. The issue to bear in mind there is how you get your encryption keys or your private keys installed securely on the CPE. It's just a cost. Again, it's common. Maybe SD-WAN might be a solution for that sort of thing. And some vendors have proposed adding an OpenStack stateful-aware firewall in there. On its own, I don't think that would be sufficient, but it will obviously make a contribution to the security of the solution being secure in depth. Backwards compatibility between releases. OpenStack has a 6-month release cycles, and currently you can't guarantee backwards compatibility between the controller version and the compute version. They both have to be on the same version. This creates a major issue for network operators because our customers exist in different planned engineering windows, so we can't upgrade all the customers at the same time. So if we've got multiple customers on the same controller, it could be almost impossible to do an upgrade without having that backwards compatibility. So essential to have backwards compatibility. Some services today are backwards to N-1. There's some API tools out there that will help you do this. It's hard work, but there's tools there that help you. Some organizations have reported running different releases of controllers and compute, and there's one that's referenced there. But the problem with distributed NFV is that we want multiple releases of the same service. It's not just about each OpenStack service running, like Nova running a different release from Neutron. We want different releases of Neutron, or different releases of Nova at the same time. So I don't think this is yet adequately addressed by OpenStack. So there's certainly an operational issue there. So back to challenge 1, which takes a bit longer to explain and understand. But a VNF will number its interfaces according to the sequential order OpenStack brings them up. To the first interface it sees, it'll probably call Ethernet 0, next one Ethernet 1, next Ethernet 2. And how that VNF uses those interfaces, the only way you can tell is really to read the documentation for that VNF. Read the documentation. It says, this VNF, this first interface it will use for management, second one LAN, third one WAN. And then you have to write a script that makes sure that when you install that VNF, you install the interfaces in the right order. And this is very important because if you imagine a firewall and you get the WAN and the LAN interfaces the wrong way around, it's not a very good firewall. You know, that could be career limiting for a CIO. So this is definitely a problem. And a subsequent problem of this is what happens if you disconnect and reconnect. And we've tested this, and basically the outcome is non-deterministic. You know, you don't know in advance, unless you know the internals of how the VNF works, what's going to happen. You know, it can sometimes come back as the same interface can come back as a new interface, or in some cases the VNF just locks up. So how can we fix this one? Linux has this consistent device naming, was introduced in 2009, which means when interfaces are reconnected, they have a consistent name, which is really good. You know, it does help us. But today, not all VNFs use Linux, so you can't always make that assumption. So it would be cool to have somewhere where we could pass some metadata between the OpenStack and the VNFs, so that OpenStack could give the VNF some hints about this is your management interface, this is your LAN interface, this is your WAN interface. And then you could perhaps do something to validate that topology. But I've not seen that proposed, and there may be issues because that's not a very cloudy way of doing things with getting that implemented in OpenStack. So this is kind of a mind map of where I think the overall solution is. So score today, 4 out of 6, so that's not bad. The green things are things I'm happy with. The yellow things are things that, you know, I put a warning around, and red things are things I'm really unhappy about. So choices for distributed scaling, you've got the cascading approach. My concern there is how much resources you just put into the controllers. And if you do that, then you've got to think about controlling stampedes, but there are mechanisms to do that. In the middle, we've got the controller per node architecture, and some vendors have implemented that. And my main concern there is about the amount of resources you consume on each node, especially when nodes are particularly small. And then the third option is not to use OpenStack at all. And the main concern there is the complexity then you're pushing into the orchestration layer. In the middle, we've got all this thing I've just talked about, issues with consistent interface naming and how do you know it's connected up together correctly. And I don't think there's a solution there that works particularly well yet. So we've got to work on that. Backwards compatibility is going to be a major operational issue for network operators, and that's not really addressed at all today. Network security, there are solutions there, and I think I'm happy that we know how we can solve that. And then choices for service chaining. We can use the service chaining framework, and that's nearly ready. I've seen proof of concepts of that, and that's looking cool. You could use an SDN controller, and there's lots of solutions out there that use SDN controllers, but is that just adding a layer of complexity you don't need for virtual CP? And then there's network services header, and that's great for internode connectivity, but probably overkill for intranode connectivity. So my conclusions and the next steps. There's several tractable and competing solutions of the 4 of the 6 challenges out there at various stages of maturity. The challenges are not fully met yet. You know, there's still the name binding issue, still backwards compatibility. I'm quite happy that there's a limited number of competing solutions. It's not a vast number. So it's kind of in a healthy situation right now. And my next steps, and indeed the industry's next steps, are to develop and test these proposed solutions. Thank you very much for listening. Okay.
Thanks, Peter. Peter covered that in record time, so we've got about 4 minutes left for questions. So who wants to start us off? If you have a question, please state your name and your affiliation. Right here in the front. Yakov?
Just a quick one about your statement about not using NSH. Okay, thank you. Not using NSH for an internal kind of situation. Do you think that it might be useful when you would like to pass metadata between different VNFs on the same platform? Think of things like DPI as a service or something. Would that change your mind?
Maybe. It still feels overkill when all you're doing is you just pass it. Actually, the packet might not move; it might be stuck in memory, and you're just passing a pointer, aren't you? So it just seems overkill. Yeah.
VNFs maybe by different. If you have separate VNFs, perhaps from different vendors, and you'd like to somehow consistently moving information from them.
Yeah.
I think that the only way to do it right now in a standards way would be NSH.
Yeah. So it might be.
So it might be useful.
Yeah. I'd look at it for that. Yeah.
Anyone else? Okay.
Yeah.
Thank you. So that takes us to the coffee break, and we'll be back at 10:20 this morning. Thank you.